Okay, let's do this. We're going to write piecewise functions. All right, so we have a graph. I'll put it in color. I'll color code it so you know which one's which. Uh-oh. It's going to take a little time. Just needs to catch up. There we go. Okay. So let's say this part, and you see how it connects? That means that from this side or the other side, you have one of them has to be solid and one of them has to be an open circle. You can pick. Okay, I'm going to go ahead and do solid first. So my function is going to be something like this. So it's f of x equals, so I'm going to do my red one first. So this graph right here, this is just a regular x function because it is any place I pick, it's going to be up 1 and over 1. Okay, so it's regular x. Okay, and this is only good for values of x that are less than 0. Okay, because we want everything that's on this side of 0. So basically that's what we're graphing. Okay, and because we're going to be utilizing that point, we're going to use underline for representing the equal part. Okay, this function here, you see that? This function there, okay, it can't also be equal to, so we have to make it an open circle. So whatever that is, okay. So this function is a up to and over 1. So this function is a 2x function. It goes through the 0, so you can put plus 0, or you don't have to. And this one's going to be for x values that are greater than 0. Okay, and it's not equal to 0, so because we chose to have the red side equal to 0, and that means that we're going to be, the red one's going to have an underline because it's equal, and the blue one's not going to be underlined, so therefore we're not going to utilize that. Okay, that's all it is. Okay, that's the next one. Now this one, they deliberately tell us that, hey, it's not going to be equal to. So, okay. So we're going to have a function. Okay, this function looks like it's a up 1 over 1. Okay, so the function looks like it's a slope of 1 only. Okay, so this is going to be a 1x, which is an x. Okay, but it's unlike this previous one where it's centered at the origin because the y-intercept is 0. This one, if I keep going, it's going to actually hit it right here at this spot right here. That's 1, 2, 3, 4, 5. So it's going to be x plus 5. Okay, and I only want it for values that are less than -2. So you see that? Less than -2 only. So it's going to be x less than -2. And it's open circle, so therefore I do not use an underline. Okay. This one here, you see the shaded in. So it starts right at -2. So I do know that it's going to be for values that are equal to -2. Okay, and I also want things that are onto the right hand side. So I want x is bigger than -2. And this is a flat line, which means that it's a value of, the function f of x equals -2. And it actually makes a whole flat line like this. But because we only want it for values that are bigger than -2, which is in this direction, we only want it for that much, and therefore we can delete the left hand side. Okay. This one here, this is going to be f of x. This is 3-piece. Okay, so I have, it's equal to -1 right here, equal to -1. And I want everything to the left of that. So before I even do anything, I can just say I want x's that are less than or equal to -1. Okay, just by looking at that. Now, what is my function? My function is going to be just a regular up 1 over 1. So my function is just going to be an x function, but it doesn't hit it at 0. Actually, if I keep going up 1 over 1, it's going to hit it at 1, 2. So my y-intercept is +2. Okay. This middle one, it's not going to count -1, or it's not going to count 1. Right? So this one's going to be x that lives between -1 and 1. Okay. Actually, I need a little bit of space. Move it over. Okay. For that one, the slope, if you look at here, it's up 1 over 1. So it's exactly the same. So it's just an x equation, but it does hit it at this spot right here, which is at 3. So it'd be x plus 3. Okay, and the last piece, we do count 1, and it's going to go past that. So this one has a slope up 1 over 1. So I know that I have to do a slope of x, or 1x, and then if I keep going, or if I keep going backwards, it's going to hit it at positive 1. So it'll be x plus 1. And this is only for values of x that are bigger than or equal to, okay, it's bigger than because it's all on this side. So all this side is going to be, greater than 1. And it's also equal to 1. So we have to use an underline. Okay, this one here, f of x equals, okay, again, we can see that this is a continuous function, so you can pick and choose where you want it to be equal. I'm going to go ahead and pick, for this one, I'm going to go ahead and pick it as being equal to, so this one. So I know that I want everything that's value of -2 and less. So when I'm done, it's going to be x is less than or equal to -2. Okay, I already know that. I just got to figure out what the slope of this line is. Okay, and it looks like I'm looking for places where it hits at the corner. So it looks like right here. So it looks like it's up 3 and over 1. So I know my slope is going to be 3x. Okay, but I need to know where it hits this y-axis, y-intercept. So I have to keep going on that. All right, so up 3 over 1, and that's the pattern. So if I keep going, it's going to be up 3 over 1. Right, so I'm right here. Which right now I'm at what, 1, 2, 3, 4, 5, 6, 7. Right, and if I go up 3 more, I'm off the charts. Well, actually, I can up 3 more, so 7, 8, 9, 10, and over 1. So I'll be at 10. So this line's going to hit it at y-intercept of 10. So 3x plus 10. And that's only for values of x that are less than -2. You can see that this one's actually easily symmetrical. So I can actually do that. This one's going to be the same thing. It's going to come, it looks like it's going to go down 3 over 1. So if I do that, it's going to be down 3 over 1. And then from there, it'd be down 3 over 1. So it's going to come from 10 as well. So it'll be plus 10, except this one's going to be -3x. Okay. And I need it for values of x that are less than, or excuse me, greater than. So I typically don't like to go out of order, but this is for x values that are greater than 2. So we want everything on this side. And you can see how I'm shading in the side where the line is. So x is greater than or equal to 2, right? So by doing that, I've essentially said I'm going to count this point, which is x equals -2 or x equals 2, and I want everything bigger than that. And on the right one, I'm essentially saying I want everything in there, which is -2, and everything smaller than -2. Okay, so that leaves me my green piece, and because I'm counting those, I can't count these spots right here. So I want everything that's in between -2 and +2. So this is going to be -2, and I want x that are bigger than that, and I want x that's less than +2. Okay, and that's a flat line at 1, 2, 3, 4. So this is just going to be the equation f of x equals 4. Okay. This right here, if you haven't been exposed to this yet, this is called a step function. Okay, step function is made up of, it looks like a step, right? Like a little stairway, but it's made up of horizontal line segments. Okay? So the first piece starts at x equals 0, and it goes all the way to 2, but it doesn't count it. So if I write it, I can say it starts at x equals 0. So here's 0, and it actually equals that. And it's bigger than that. Okay, so it's bigger because it's on the right-hand side of 0. Okay, but it is less than 2, and it doesn't count 2 because it's an open circle. So it doesn't count 2, so therefore I don't underline it. And this equation, it's going to be a flat line right here, which is the line y equals 1. So or we can call it f of x equals, oops, wrote it wrong, 1, right? So f of x equals 1. Okay, next piece. Okay, this is the line f of x equals 1, 2, 3. So I'm going to start with 3. And it's only good between 2, and it's going to count 2, and it goes all the way to 4, but not counting 4 because it's open. So like that. Okay. Last piece, it's going to count 4. It's a flat function. It's not going to count 6. It's a flat function. This function is 1, 2, 3, 4, 5. So it's going to be the function 5. And this is only good between 4, counting 4, so I'm going to underline that, and not counting 6, so I'm not going to underline the 6th.